Okay guys, real quick on this last example, I know the sound got super weird for some reason on our video, so let me just go through this last example real quick. Like most formulas, when you're doing this calculating payments, these are loan payments, so the example they give was, you know, if you went out and bought a car, you're going to pay it off over time typically, right? Instead of paying cash for the whole thing right away. It could be a house payment, whatever, student loan payment. So as we're looking at these loan payments, like a typical formula, it's just about applying the formula, plugging in the numbers. So what we're seeing on this to calculate future payments is on the left side you're taking the present value, and then we're plugging in some other numbers here. I wanted to show you the formula really quick. It's on the bottom of page 303 in your book. Let me pull that up for you. It looks like this. So you have the present value. So if you went out and bought a $16,000 car, or sorry, in the one they give, they said we bought a $19,000 car, but we gave a $3,000 down payment, right? So the amount that I'm responsible for would be the remaining $16,000. So our loan present value is $16,000. R represents the payments that you're going to make each month, and typically that's what we are solving for. So most likely we will be getting a number out of this and then dividing it into the present value that we owe. So some of these guys, just to make sure we recognize where they're coming from, this value of I, like in previous problems, it represents the rate broken up over periods of payments, right? So if I have an annual rate, like the one I'll show you in a second, if I have an annual rate, but I'm making payments monthly, then they need to take my annual rate and divide it by 12 so that they can convert it into monthly values, right? And so that's one thing you'd see up here if you want to look at the book's example on this, right? It was a 6% interest per year, but it's being paid off monthly. So they took that 6%, they divide it by 12, and this becomes the I value. So that's what we're getting out of this guy. And then N represents the total number of payments. So for the example we're about to see, you do have to figure out if I am paying monthly for, say, 3 years, then my N value would become 12 times 3, right? It's monthly over a 3-year period, and so I get 36 as my total number of payments. So just wanted to make sure you were familiar with the formula so you could plug in the proper numbers. And so that's all what's going on in this example here. So we owe $16,000 on the car after our $3,000 down payment. We are solving for R. R is what we are going to pay each month, right? And that's typically what a person wants to know, right? They're going to buy a car and they say, okay, what are my monthly payments? Because they plan on financing it, right? Instead of paying it all right off the bat in cash. So just to make sure we're clear on some of the numbers, it's super similar to the compound interest formula, with just a little bit added in here, as well as our negative value, because we are moving forward from this present value that we have here. So we had our interest rate of 3.1%, but notice that was an annual percentage rate. So this is per year. So what they did for the I value here and the I value here was again to take the annual rate and divide it by 12, because we're not paying it at the end of each year, we're paying it at the end of each month, right? And so they're breaking up the interest over 12 periods. So that's the I value in those locations. And then again, N represents total number of payment periods. So this was monthly payments for 3 years, right? So it's a total of 36 payments, and that's the exponent that you see. From there, it's real basic algebra. We're just getting a number value out of this, dividing it into 16,000 to figure out how much we're really paying over time. So if you look at this one, we would interpret this as her paying $466 a month. Remember, it's 36 months, but the reason they say for 35 months and then slightly less in the final month is because as you make your final payment, in the final month, interest doesn't have time to accrue in the final month after you've made that payment. So it's paid off, and the interest is not continuing to build. So that's what you're looking at. But realistically, it still would be close to that $466 for 36 payments. So if you did figure that out, I was going to show you really quick. All right, so if I paid $466 for 36 payments, Even if it's slightly less in the final month, it's still going to be close to this total. So what are we really seeing here? $16,000 loan, she's really paying $16,776. So we're looking at the extra in there as the interest that she's paying, right? So she's really paying more for this car than what it's worth because of the interest that's being added on as she pays it off over time. So she's really paying an extra $776 in interest because she isn't paying it off right when she gets the car, and she's taking time to do it. And so that's the literally the price you pay for not paying cash for it and trying to pay it off over time.